Do not forget, you can support the channel with a like, and you can also subscribe to be aware of the latest published videos. Thank you. We hope that here you can find the latest news, ideas, and discoveries from the scientific world.
Scientists uncover backyard fungi that can break down the toughest plastic in 140 days. During laboratory testing at the University of Sydney, the Aspergillus terreus and Engyodontium album fungi consumed 100% of polypropylene samples, a hardy plastic used in bottles and food containers, within 5 months. A 2020 study published in ACS Sustainable Chemistry and Engineering found that humans generate 400 million tons of plastic per year. Much of that plastic is polypropylene, a sturdy material often used to make bottle caps, food containers, and plastic wrap. Typically, polypropylene can take hundreds of years to degrade, and with the growing amount of plastic waste annually, the waste is piling up. Researchers at the University of Sydney think they have developed a solution to the world's growing plastic waste problem: plastic-eating fungi. As the team described in their published study, the Aspergillus terreus and Engyodontium album fungi consumed 25% of polypropylene samples within 90 days. By day 140, the fungi had consumed 100% of the polypropylene samples. The results of the study shocked University of Sydney graduate student and study lead Amira Farzana Samad and chemical engineer Ali Abbas. It's the highest degradation rate reported in the literature that we know of in the world, Abbas stated to the Australian Broadcasting Corporation, ABC. In order to produce these lab results, Samad and Abbas first needed to heat the plastic samples using UV lights, chemical agents, or other sources of heat. This process would soften the plastic and make it easier for the fungi to latch onto it. Then, the fungi could start consuming the plastic at a greater efficiency rate. While the results of the initial study are promising, there are still issues with accountability and large-scale application. First, the process of scaling up the experiment to a macro level, one that can tackle the world's industrial-sized plastic problem, will take a minimum of 5 years of trials. Second, researchers worry that the results of the study could curb efforts to reduce plastic waste. Evidently, if there are rapid ways to break down plastic, many will not feel the need to reduce the amount of plastic they consume regardless of whether these breakdown methods are in use. The technology itself may be ready, as we said, within the next few years. That, however, will not solve the problem alone. We need the behavioral issues, we need the social issues, we need the business issues. All of these need to be resolved around the plastics problem. The technology is only half the solution, Abbas stated to ABC. Additionally, researchers acknowledge that the fungi are not optimal for breaking down highly crystalline forms of plastic that are common in commercial materials. Because of this, experts emphasize the need for a multifaceted approach to the plastic waste problem. Despite these limitations and concerns, the researchers are aiming to expedite the degradation process and remain hopeful that their study will positively impact the world. In particular, Abbas is confident that the process can be scaled up to industrial levels within a couple of years. It is scaling up which is very much similar to any kind of fermentation process, he said to ABC. That technology already exists for those processes, and we're able to now borrow that learning from chemical process engineering and bring it into this particular process here. Currently, the team is working on a prototype, testing ways to speed up the degradation process, and assessing the economic and environmental factors of potential commercial use. If the team can transform the laboratory solution into a commercial-scale plastic waste management system, the world will finally have a promising solution to tackle one of our most pressing environmental issues.